So this is an example of the lemonade stand from this most recent assignment. Please feel free to slow this down or reverse it. I'm gonna try to go at full speed so we can fit it all into one video. So it's important to read the information first. It says the data table below shows the amount of money in the cash box at the lemonade stand after a certain number of sales. Use the data to create a graph in order to answer the questions that follow. Notice that it gives us the number of sales in glasses up to 5 to 30. That's what is changing. We're gonna say that's our independent variable. And then as a result of that, the money in the cash box in dollars goes from $6.50 with 5 glasses in there up to $14 when there's 30 glasses in there. That's gonna be our dependent variable. So the first thing that we need to do to make a proper graph, we need to title the graph. So we always know that it's going to follow the format of Y versus X. So we're going to have money in cash box versus number of glasses sold. So we're going to have money in dollars over here, and down here for the independent variable, we'll have number of glasses sold. And I guess officially the units are just numbers of here. To figure out how to scale these appropriate, we're gonna have to look at the maximum value of each and then calculate them. For the x-axis, we're gonna take the maximum number of glasses sold, which says is 30, and divide it by the number of boxes along the x-axis. If we count the number of boxes along here, we come up with 15 boxes. And 30 divided by 15 is 2 glasses per box, which means down here we need to mark this, we need to scale this by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and it's a perfect 30 for there. Along the y-axis, we're going to have the dependent variable, and the biggest value we have here is $14. So along the y-axis, our maximum dollar amount is $14. The number of boxes, if we count up 0, 1, 2, we end up with 15 boxes up here. And 14 divided by 15 turns out to be $0.93 per box. Now, obviously, we can't go up by $0.93 or 93 cents, so we're going to round that up to $1 per box, which means we can go ahead and mark this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and $15 is the values we have here. Next, we're gonna need to, we already labeled our axes, we're gonna need to plot those points at this time. So at 5 glasses, which would be approximately here, we have $6.50. So $6.50 would be coming up here, and it'd be right between the 6 and the 7, and we'll need a point protector around there. When we have 10 glasses, we're at 8, 10 glasses, we're at 8, and again, a small point with a big point protector. That blob is bigger than I would prefer. 15, we're at 950, halfway between 14 and 16. We're at 950, which is also be halfway between 9 and 10. So we have a point protector here, 20 and 11, 20. We're going up here, and we've got exactly 11 lined up here. We've got a point and a point protector. 25 and 1250. 25 would have to be 24 between 24 and 26. 1250 is right in the center of this graph, or between 12 and $13 over here. And lastly, we have 30 glasses is plotted at $14. Next up, we'll have to pull out our ruler. Unfortunately, all my good ones are at school, so I've got this massive ruler, We're going to draw a best fit line, making sure that we go through all the points as well as the y-axis. Next up, they've asked us to draw a line of best fit. We just did that. We need to find 2 slope points along there. Now, it turns out that the slope point that we have right here is perfect, and that one is at 20, that's a number, that's 20 glasses, comma, and that's at $11. See if we have any other perfect ones. It turns out that it's another plotted point. That's very unusual that our plotted points are also going to be our slope points. And at this one, we're at 10 glasses, and that's at $8. So we can use these values to calculate our slope. I'm going to scooch this over here so we can focus on calculating the slope. I have over here change of position divided by change in time. That would only be correct for a position versus time graph. So our y-axis is going to be the change in money divided by the change in glasses. So our second value, our second money value is $11 minus our starting value. Our first point for values is $8. And down at the bottom, we have the difference in number of glasses. So we've got 20 glasses minus 10 glasses. $11 minus $8 is $3 divided by 20 glasses minus 10 glasses is 10 pairs of glasses. And $3 divided by 10 is $0.3 per glass, or 30 cents per glass. So what is the specific meaning of the slope? For every 1 glass, the value of the cash box increases by 30 cents, or $0.30. That's for every glass sold. The money increases by that value. Next up, we need to know what the y-intercept is. If we take a look over here at the y-intercept for our graph, where does the best fit line cross the y-axis? It turns out that it's at $5. So the y-intercept of any graph tells us the y value when the x value is 0. So in other words, this is how much money did we have when we had sold no glasses. And this says that the amount of money was $5. So in general terms, it's the amount of money in the cash box when we had sold no glasses, or in other words, how much money was in the cash box before we sold a pair of glasses. So maybe like the starting amount. Maybe you put $5 in there so you would have change to pay for other people. At that point, we now know that the slope of the line represents how much money we made per glasses sold, which is about 30 cents per pair of glasses. And the y-intercept of our graph represents the starting amount of money in the cash box before we had sold any glasses, which was $5. I hope that helps.